This is Unit 7, Day 1, Exponential Growth and Decay. And we are going to start off with exponential growth. We have an exponential function, and how do we know it's an exponential function? Because it has x as an exponent. Now, this one we're dealing with first is exponential growth, and that is only because b is greater than 1. So the functional graph is similar to, I'm going to plot my point at 0, 1, and I'm going to just draw a general graph of this exponential function. Now, of course, you know, for a more accurate graph, we will plot points and go from there. The domain is going to be negative infinity to infinity. The range is going to be, remember, domain is your x values, and the range is going to be your y values. Well, you notice there's nothing at the bottom half of the graph. So my range is going to go from 0 to infinity. The x-intercept is, it actually never crosses the x-axis. So that should give you a hint that I'm going to have an asymptote. It never crosses the x-axis, so we have none. The y-intercept is 0, 1, where it crosses the y-axis. And my asymptote is the line y equals 0. And if you want to graph y equals 0, go for it. But you should know this is the y equals 0 line. It will never cross that line. It will approach it, but never cross it. Okay, here's an example where we have an exponential growth because the base is 2 and 2 is greater than 1. So we're talking about growth. And I'm going to plot a couple of points. So if I put in -1, 2 to the -1, this is going to give me 1/2. 2 to the 0 is just going to be 1. And 2 to the first power is going to be 2. Now, if I wanted to plot these points, I'm going to go over to -1, 1/2. And I'm going to go 0, 1, and 1, 2. So this is the idea of what my graph is going to look like. So let's talk about my domain and range. Well, my x values, or my domain, is going to be negative infinity to infinity, or all real numbers. The range is also going to be from 0 to infinity, very similar to the original graph. The asymptote is going to be the same as the original graph because we didn't shift. And the y-intercept is going to be 0, 1 as well. Now remember for your transformations, okay? So we have our function, any function, and the things that are outside of the function, that mean things that we are multiplying the function by, they will give me not a reflection, they will give me a stretch. Well, they will give me a reflection if they're negative, but they will give you a reflection if it's a negative. It also is going to give me a stretch or compression. So that is for the outside of the function. Okay, so inside of the function we have now for this is an exponential function, so we consider this inside the function. And if I'm adding or subtracting any number, well, I'm going, remember, it's going to shift my graph to the left and to the right. But remember, we do the opposite. So if it's a positive number, we're not going to go to the right, we're going to shift it to the left. If it's a negative number, instead of going to the left, we're going to shift it to the right. So this gives me a left and right shift, but remember, it's opposite of what the sign is. Now, outside the function, I'm adding or subtracting something, any number outside the function, it shifts it up and down. And that goes according to, if it's positive, it goes up. If it's negative, it's going to go down. Okay, here's an example. I'm going to do 2, and I expect you to do 3. The function, we have a plus 3 adding on the outside. So that means that I'm going to go up 3. Well, the x minus 1, we consider that to be inside the function. So the negative, well, we're going to do the opposite. So instead of going to the left, I'm going to go to the right 1. And if I wanted to graph this, let's get a couple of points here. So I'm going to have my x and y. And the points that I'm going to pick are -1, 0, and 1. So if I put in -1 for x, I'm going to get 3.25. And let's do that. We have 2 to the -1, so that ends up being 2 squared, or so -1 minus 1, 2 to the -2 power, and we're going to add 3, and we have 3.25. If I'm going to do 2 to the 0 minus 1 plus 3, I get 3.5. And if I do 2 to the 1 minus 1, and I'm going to get plus 3. It's going to give me plus 3 plus, second, too many 30s. We're going to get 4. So I'm going to plot these points to give me a guide. So -1, 3 1/4, and 0, 3 1/2, and 1/4. And of course, you can always put this in your graphing calculator and take get an idea of what the graph looks like, y equals okay, so this is what our graph looks like. And of course, we could have done the table before to help with 1 is 4, -1 is 3.5, and 0, we wanted to use that. -1 was 3.25, 0, 3.5, 1, 4, or however many points you want to use. Okay, so going back to our graph, we should know that, or you should notice that the domain, the x values did not change. They're still going to be -infinity to infinity. However, the range changes a little bit. It looks like it's going towards 3, but never quite crossing that 3 line. So my y equals 3 is going to be my asymptote, but my range is going to be from 3 to infinity. Where it crosses the y-axis is going to be 3.5. Okay, you're going to be responsible for doing 3 on your own.